Have you ever wondered if it's possible to travel across the universe in the blink of an eye? The vastness of space and the intricacies of time hold countless mysteries for us to unravel. One such enigma is the concept of wormholes, conjectured pathways offering shortcuts through space-time. In this video, we'll delve deep into the fascinating theory of wormholes, exploring their potential existence and implications. So strap in and prepare to embark on a journey across the cosmos, exploring the fascinating theory of wormholes. Imagine a tunnel, a shortcut through space and time, connecting two distant points in the universe. This is the concept of a wormhole, a theoretical passage through space-time that could create shortcuts for long journeys across the universe. To simplify this concept, let's consider a piece of paper. Now, imagine that this sheet represents our universe. If we mark 2 points on either end of the paper, the quickest route between them is a straight line, right? But what if we could fold the paper so that these 2 points meet? The distance is significantly reduced. This concept of bending space is the basic idea behind a wormhole. A wormhole is like a tunnel with 2 ends, each at separate points in space-time. This means that the wormhole could potentially have one opening in the present, and the other opening could be in the past or future. Or both openings could be present in the same time, but at different points in space. It's a concept that sounds straight out of a science fiction novel, yet wormholes are entirely possible according to the laws of physics. It's important to note here that wormholes are purely theoretical at this point. While they exist in equations and scientific theories, we have yet to observe one in the natural universe, but that doesn't mean they don't exist. It's a bit like black holes were a few decades ago. We had the math that predicted their existence long before we had the technology to observe them. Einstein's theory of general relativity, which describes gravity as the warping of space-time by energy and matter, allows the existence of wormholes since it allows the space-time fabric to bend. However, the theory also predicts that these wormholes would be highly unstable and would collapse instantly if anything tries to pass through. So, a wormhole, in essence, could be a cosmic shortcut, a bridge connecting two far-off points in our universe. But whether we can ever harness their potential is a question that remains at the forefront of modern astrophysics. The theory of wormholes comes from Einstein's theory of general relativity. This groundbreaking theory, published in the early 20th century, radically changed our understanding of the universe. It postulates that gravity is not a force, as previously thought, but a curvature of space-time caused by mass and energy. Now, what does this have to do with wormholes, you might ask? Well, if space-time can be curved, it suggests that it can also be twisted and bent into complex shapes. Imagine a flat sheet of paper representing space-time. If you put a heavy object on it, the paper bends, representing the gravity caused by the object. Now, if you were to fold this paper in such a way that 2 distant points touch, you would have a shortcut between these points. This, in essence, is the concept of a wormhole. The idea is that a wormhole could connect 2 distant points in the universe, creating a bridge or tunnel through space-time. In theory, if you were to enter a wormhole, you could emerge somewhere else in the universe instantaneously, bypassing the vast cosmic distances. But this is where the theory gets even more fascinating. Wormholes are not just limited to connecting different regions in our universe. They could potentially link different universes altogether, or different times within the same universe. Yes, you heard it right. If wormholes exist, time travel might not just be a topic of science fiction. However, it is important to note that all these ideas are purely theoretical. As of now, there is no concrete evidence to support the existence of wormholes. The mathematics of Einstein's general relativity allows for them, but that doesn't mean they do exist. In theory, these space-time tunnels could exist, but finding one or creating one is another story. The quest to understand wormholes and their potential implications continues to be one of the most intriguing pursuits in the realm of theoretical physics. Wormholes, while fascinating, present a plethora of challenges. The very idea of them, these shortcuts through space-time, sounds like something straight out of a science fiction novel. But if they do exist, There are a number of hurdles we'd need to overcome before we could use them as cosmic shortcuts. One of the biggest challenges is the need for negative energy. Now, this isn't some kind of evil dark side force we're talking about. In the realm of physics, negative energy is a hypothetical type of energy that's less than zero. It's believed that this could counteract the immense gravitational pull within a wormhole, preventing it from collapsing in on itself. However, the problem is that we have yet to discover or create negative energy, making it a significant roadblock. Then there's the issue of instability. Wormholes, according to current theories, are highly unstable. They open and close so rapidly that it would be impossible for anything to pass through. Some physicists propose the use of exotic matter to stabilize them, but again, this is purely theoretical and has not been proven or observed. And let's not forget the big question. Could anything actually survive traveling through a wormhole? The immense gravitational forces, the rapid opening and closing, the potential radiation, it all sounds rather perilous, doesn't it? It's a question that we don't have a definitive answer to, and it's one that continues to puzzle scientists. Even if we could stabilize a wormhole and had negative energy at our disposal, there's another hurdle: size. Theoretical models suggest that natural wormholes, if they exist, would be incredibly small on the scale of quantum particles. We're far from being able to send anything, let alone a spacecraft, through something that small. Despite these challenges, the concept of wormholes continues to captivate scientists and space enthusiasts alike. The idea of shortcuts through space and time is too tantalizing to ignore. And the pursuit of understanding and potentially harnessing wormholes is a testament to human curiosity and ingenuity. Imagine the possibilities if we could harness the power of a wormhole. It's a thought that tickles the imagination, inviting us to dream of a future unbound by the constraints of time and distance. Firstly, let's consider the potential for space travel. Today, the farthest reaches of our solar system remain largely unexplored, primarily due to the vast distances involved. It would take us nearly 75,000 years to reach the nearest star, Proxima Centauri, using current rocket technology. But what if we could create a shortcut? A wormhole, a kind of cosmic tunnel, could theoretically allow us to traverse these mind-boggling distances in a blink of an eye. We could venture into the farthest corners of the cosmos, exploring distant galaxies, and perhaps even meeting other forms of life. Now, let's shift our gaze from the stars to the fabric of reality itself. If we could manipulate wormholes, we'd gain a powerful tool to probe the deepest mysteries of the universe. We could test the limits of general relativity, perhaps even shedding light on the elusive quantum gravity. We could observe phenomena that are currently beyond our reach, like the interiors of black holes or the singularity at the beginning of the universe. But the potential of wormholes extends beyond mere scientific curiosity. What if we could use them to communicate instantaneously across vast distances, essentially creating a cosmic internet? Or what if wormholes could enable time travel, allowing us to revisit the past or glimpse the future? Of course, these are all just theories, a testament to the power of human imagination and our relentless pursuit of knowledge. But who knows? As our understanding of the universe deepens, these wild ideas might just become reality. A wormhole could open up a whole new realm of possibilities for humanity, forever changing our place in the cosmos. So, what have we discovered about wormholes today? Well, quite a bit, actually. We've explored the idea of these fascinating structures, bridges through space-time, connecting different parts of our universe in ways we can hardly imagine. We've delved into their theoretical foundations, rooted in the mind-bending equations of Einstein's general relativity. We've also grappled with the challenges they pose. These aren't just astronomical puzzles, but fundamental questions about the nature of reality itself. Can wormholes exist? Can they remain stable? And if they can, could we ever traverse them without being torn apart by the unfathomable forces at play? And let's not forget the tantalizing possibilities they present. Wormholes could be the key to interstellar travel, making the vast distances of the cosmos surmountable. They could allow us to literally reach out and touch the stars, or they might reveal new dimensions of existence, realms beyond our everyday perceptions of space and time. But for all we've learned, much still remains unknown. Theoretical predictions and mathematical models can only take us so far. We need empirical evidence, direct observations, to truly confirm the existence and properties of wormholes. While the reality of wormholes remains to be discovered, one thing is certain: they offer an intriguing glimpse into the mysteries of our universe.